Right now, you've got these legacy car companies building essentially 2-ton electric missiles.
Oh, absolutely.
Cars that can go from 0 to 60 in like 3 seconds flat.
Yeah.
But, and here's the wild part, why are those exact same multi-billion-dollar companies completely failing at getting those exact same cars to, safely drive themselves to the local grocery store?
Well, because they're running headfirst into the reality that bending metal on an assembly line and writing cutting-edge artificial intelligence, they just require entirely different corporate DNA.
Yeah.
I mean, you really cannot solve a complex data problem by just building a slightly better factory floor.
Right, which brings us to exactly why we're here today.
Yeah.
Because to figure out how these legacy companies actually survive this brutal transition, we're doing a deep dive into a highly specific, honestly eye-opening paper.
It really is.
Our mission today for you, the listener, is to explore the future of mobility. And we're using a source called Future of Mobility, SFC&C Innovation Paper Follow-up. This was just published in May 2026, so it's incredibly fresh, within the UK Salesforce consultants and contractors community on LinkedIn.
And, to really understand why this paper matters so much, you have to understand the author, Dovydas Mockevicius, because he actually founded that very LinkedIn community.
Yeah.
And his perspective, that's what makes this deep dive so crucial.
Totally.
He's not, a traditional automotive engineer trying to squeeze out more horsepower. And he isn't some dealership owner just looking at quarterly sales. He is an enterprise architect.
Which means he looks at the entire global mobility landscape as this giant interconnected web of data. Like I was looking at his Trailblazer profile and his LinkedIn, and they read like a literal roadmap to the cloud.
Oh, absolutely.
Like he's the CEO at IS Cloud, right?
Yeah.
And he has driven digital transformations for businesses across 26 different countries.
26? That's a massive footprint.
Yeah. And in the Salesforce ecosystem alone, he holds 17 different certifications.
17, covering, Sales Cloud, Service Cloud, the core platform, CRM analytics. And he's got 2 super badges, 248 Trailhead badges.
248.
Yeah, 248. Plus, he's a 2025 Agent Blazer champion, and he's actively on the path to becoming a Salesforce certified technical architect. So a CTA.
Which is incredibly rigorous. And when someone with that kind of deep systemic background in enterprise architecture actually analyzes the automotive industry, they aren't looking at the paint job.
Right.
They're looking at the invisible nervous system of the company itself. They're asking, how does data flow from a raw lithium supplier through the robotic assembly line all the way to the customer's driveway?
Okay, let's unpack this because we need to start with a massive reality check. Dovydas made some bold predictions in a previous 2025 paper.
He did.
And now we have his 2026 follow-up. And the contrast between what succeeded over the last year and what just totally stalled out is stark.
Let's look at the physical side first, right?
Yeah.
Where electric vehicles are actually seeing a huge win.
Yeah, the physical adoption has been phenomenal. EVs have successfully hit roughly 20% of new car sales globally.
20%.
Crossing that 20% threshold is monumental. It means EVs have completely moved out of that early adopter phase.
Like the tech enthusiasts.
Exactly. Now they're an undeniable mainstream reality. Production costs have plummeted, charging speeds are way up, and you've got innovators like BYD, CATL, and XPeng pushing what we call software-defined vehicles into markets everywhere.
Okay, wait, let's define that for the listener, because software-defined vehicle, that can so easily sound like just another marketing buzzword.
Fair point.
What does that actually mean when you're just, sitting in the driver's seat?
Well, it means the car's core functionality is governed by its operating system rather than just its mechanical parts.
Okay.
So in older vehicles, if you wanted a more efficient braking system, you basically had to take the car to a mechanic to install different brake pads. Right?
Yeah, manual labor.
Right. But in a software-defined vehicle, the manufacturer beams an over-the-air data update to the car's computer while it's just parked in your garage overnight.
Oh, wow.
And the next morning, your regenerative braking algorithm is suddenly 10% more efficient. The software physically governs the hardware.
So the hardware and the software for that basic driving experience, that's advancing rapidly. But then we hit the self-driving speed bump.
Huge speed bump.
The dream of full autonomy has just hit a brick wall for traditional legacy automakers. I mean, you've got brands like Mercedes-Benz, BMW, Stellantis. they're pausing, canceling, or entirely reprioritizing their autonomous programs.
Yeah, the rollback is real.
Even Tesla missed its huge promise to offer robotaxi services to half the U.S. population by late 2025.
Right, and what's fascinating here is that we have to draw a really sharp line between level 3 and level 4 autonomy to understand why this failure is happening.
Break that down for us.
So level 3 means the car can drive itself under certain highway conditions, but a human must be in the driver's seat,
Like paying attention.
completely ready to take over the second the computer gets confused by, say, a weird construction zone or bad weather.
Got it.
But level 4 means the car handles everything completely independently within a specific geographic area. There's no human babysitter required at all.
Right, and making that leap from a human babysitting the computer to the computer being entirely self-sufficient, that is clearly where the legacy brands are failing. But why?
It's a completely different problem.
I mean, if they can build a sleek, software-defined EV with amazing battery chemistry, why is writing the self-driving code stalling out so hard for them?
Because building an electric vehicle is fundamentally still a supply chain and manufacturing challenge. It's about sourcing raw materials, optimizing factory robotics, managing global logistics.
Which they're good at.
They're excellent at it. Legacy automakers have spent a century perfecting supply chains. But level 4 autonomy, that is a pure data, artificial intelligence, and edge computing challenge.
Okay, edge computing meaning the car itself has to process the data right there on the street, rather than waiting for a cloud server hundreds of miles away to tell it to hit the brakes.
Exactly. A level 4 vehicle is processing literally millions of data points per second from LiDAR, radar, optical cameras.
That's intense.
It has to calculate the trajectory of a pedestrian stepping off a curb in real time, in the rain. Traditional car companies simply do not have the enterprise technology DNA required to solve that level of AI complexity.
They just don't have the background.
Right. They're trying to staple a Silicon Valley software problem onto a Detroit manufacturing process.
Man, it reminds me of the early days of smartphones. Like the physical hardware, the glass, the camera lenses, the battery. It was incredible engineering.
Oh, absolutely.
But what actually changed our lives was the app ecosystem,
And
the operating system. Because you can build the most beautiful phone on earth, but if the operating system crashes every time you open a text message,
then the phone is just a very expensive paperweight. Exactly. Legacy automakers have figured out the glass and the battery, but they are really struggling to write the operating system for autonomy.
and their inability to write that operating system has completely fractured the mobility landscape.
Yeah.
The dream of a universal global rollout where everyone gets a self-driving car all at once, that's over. The innovation hasn't stopped, but it has shifted entirely to highly specialized tech players who are operating in hyperlocalized regions.
Here's where it gets really interesting. Because if you look at the map of who is actually operating autonomous vehicles in 2026, it is a literal city-by-city ground war.
It really is.
Like Waymo is running real-world robotaxis in 6 or 7 specific U.S. cities, and they're doing public testing in the U.K. and Japan.
Right.
And then Tesla is still running level 3 and 4 robotaxis in a handful of U.S. cities while deploying their consumer full self-driving supervised program globally across places like Canada, China, Australia, the Netherlands.
And you cannot ignore what's happening in the Eastern Hemisphere. They are moving incredibly aggressively.
Yeah, tell us about that. Baidu's Apollo Go is operating in China and the UAE, and they're targeting a massive 26-city footprint.
26 cities. Wow.
Yeah. Pony.ai is running operations across China and parts of Europe. WeRide is deeply entrenched in China and the UAE as well.
And notice the trend there.
Exactly. None of these leaders are traditional legacy automakers. They are data companies.
So if you're listening to this and wondering why your local dealership isn't selling a fully autonomous robo-taxi yet, this city-by-city fragmentation is the answer.
Yes.
But as a consumer, it feels bizarre. I mean, you could take a fully autonomous ride to pick up groceries in Phoenix, Arizona, but if you drive 3 states over, the technology practically doesn't exist. Why is it so isolated?
Well, because level 4 autonomy relies heavily on hyper-localized 3D mapping.
Okay.
The car doesn't just need to know how to drive in general. It needs a millimeter-perfect digital map of every single curb, stoplight, and crosswalk in its specific operating area.
Wow. Millimeter perfect.
Yes. So a vehicle that drives flawlessly in Phoenix is effectively blind if you drop it into the middle of London without that specific data set.
So the bottleneck isn't just the artificial intelligence inside the car. It's the city itself.
Absolutely. The progress of autonomous driving is dictated by regional infrastructure, local regulatory frameworks, and even cellular network density.
Oh, because of the data transfer.
Right. If a local government hasn't established the laws for driverless liability, or if the city's enterprise infrastructure cannot support the massive, continuous data transfer required for these vehicles to communicate, the cars just cannot operate there. The technology is entirely constrained by geography.
And that geographic constraint perfectly sets up this incredibly startling data Dovydas presents regarding his home base, the United Kingdom.
Yeah, the UK numbers are rough.
Really rough, because if you want to see a severe regional disparity in action, the UK automotive sector is a prime example right now. The UK's automotive output has plummeted to just 0.79% of global output.
That is staggering. A drop to under 1% means the domestic manufacturing base has been structurally hollowed out.
Totally.
I mean, in 2025 alone, their overall vehicle production fell by 15.5%.
And even worse, their commercial vehicle output, the delivery vans and logistics trucks that actually power an economy, that crashed by an astonishing 62.3%.
That's 62.3%. We are not looking at a cyclical dip in the market here. We are looking at a fundamental collapse of traditional domestic production capability.
And this is the paradox. Dovydas points out, UK consumers still want electric vehicles.
Oh, the demand is there.
The demand is completely stable. So you have this sky-high consumer demand, but almost zero domestic production. And the result is this brutal price disadvantage for the buyer.
The premium they're paying is wild.
Exactly. If you live in the UK and you want to buy a mid-size battery electric vehicle, you are paying 10.4% more than someone buying that exact same car in the EU.
Right.
And you are paying an unbelievable 48.2% more than someone in Australia.
Which is just a huge gap. And the economic mechanics behind that price gap are fascinating. The UK is facing this perfect storm of high energy costs, severe constraints on local charging infrastructure, and an absolute reliance on imported vehicles.
Yeah.
So the friction of importing the cars, combined with the expensive electricity required to run them, it forces the end consumer to absorb a massive premium.
Think of it like living on an island where everyone desperately wants the newest smartphone.
Oh, okay, good analogy.
Right. But the island has no cell phone towers and no factories to build the phones. The demand is sky high, but you have to import the physical phones on cargo ships, and then you have to import massive diesel generators just to charge them.
You're paying for all that friction.
Exactly. You end up paying double what the mainland pays purely because of the logistical friction.
And that logistical friction is crushing the consumer right now. But, and this is where Dovydas highlights a very counterintuitive silver lining, when an industry hits absolute rock bottom and the legacy manufacturing structures fall away, the market is wiped clean. And a blank slate is actually the perfect environment for total disruption.
Wait, so hitting rock bottom is actually a competitive advantage?
In a highly transitional technology landscape, yes. Because if you're trying to push down the costs of EVs, electricity, and charging networks, the last thing you want is the financial burden of retrofitting a 50-year-old inefficient manufacturing plant.
Oh, I see.
The UK's structural decline means they don't really have legacy systems to protect anymore. They are forced to build leaner, fundamentally digital innovation ecosystems entirely from scratch.
Which brings us to the core thesis of the paper. How do these companies, whether in the UK or globally, actually build a surviving innovation ecosystem?
That's the billion-dollar question.
Because we've talked about battery chemistry, we've talked about self-driving software, we've talked about mapping cities, but Dovydas argues that the actual secret weapon, the thing deciding who lives and dies in this industry, isn't the car itself.
No, it's not.
It's the enterprise technology running the company.
He points out that enterprise technology is the true engine enabling innovation and efficiency. In this hyper-competitive mobility space, a company cannot survive by just designing a cool physical product anymore.
Right.
The integration of enterprise tech across the entire vehicle lifecycle, from R&D in the supply chain all the way to the manufacturing floor and after-sales service, is now absolutely mandatory. Accelerated by AI, of course.
Okay, I need to push back on this a little bit.
Sure.
Because it sounds a bit like, an enterprise architect find a problem that perfectly fits his specific skill set.
I can see why you'd say that.
Right. I mean, obviously, a founder of a Salesforce consultants community with 17 certifications thinks CRM and data integration are the most important things in the world.
Naturally.
But implementing a unified enterprise architecture, powered by AI, takes years and billions of dollars. Aren't these struggling legacy automakers better off just, I don't know, outsourcing their software needs to Microsoft or Google rather than trying to become massive software companies themselves?
I get the skepticism, but if we connect this to the bigger picture, outsourcing a basic email server or a cloud storage drive is one thing.
Yeah.
Outsourcing the core operational nervous system of a global manufacturing company, that is impossible without losing your competitive edge entirely.
How so?
Well, think about the sheer complexity of building a modern electric vehicle. You are managing tens of thousands of components sourced from dozens of different countries.
All interacting at once.
Exactly.
Okay.
Subject to shifting geopolitical tariffs, sudden raw material shortages, fluctuating shipping costs. If your supply chain software cannot instantly communicate with your factory floor software, the friction will bankrupt you before a single car rolls off the line.
Okay, so what does that seamless integration actually look like in practice? Like, how does a great CRM or tech stack actually save a car company?
Dovydas highlights the deployment of digital twins as the ultimate catalyst for this integration.
Digital twin.
Yes. A digital twin is a highly complex, AI-driven virtual replica of a physical system. Car companies are no longer just designing a car digitally. They are building a real-time digital replica of their entire global supply chain and factory floor operations.
Let's make that concrete for the listener. Walk us through how a digital twin solves a real-world crisis.
Sure. So imagine a massive cargo ship gets stuck in the Suez Canal.
Okay, classic supply chain nightmare.
Right. And it's carrying thousands of tons of refined lithium bound for an automaker's battery plant. Now, a legacy automaker relying on fragmented, outdated enterprise software, they might take 5 days just to realize that specific shipment is delayed.
5 days.
Easily. And then maybe another week to halt production, bleeding millions of dollars a day while workers just stand around waiting for parts.
Because their shipping department's software doesn't automatically talk to their factory floor's scheduling software.
Exactly. The data is siloed. But now look at a modern automaker utilizing a digital twin and a unified enterprise architecture. The exact moment that ship drops anchor in the canal, the AI running the digital twin flags the delay
Instantly.
in milliseconds. It simulates 100 different scenarios. It calculates the exact moment the factory will run out of lithium based on current burn rates.
Oh, wow.
It instantly reroutes a secondary smaller shipment from a supplier in Mexico to cover the gap. And it adjusts the factory's robotic assembly schedule to prioritize building a completely different vehicle model in the meantime.
That's wild. So the crisis is essentially solved before a human being even reads the news headline.
Yes. The software doesn't make the car drive faster on the highway. It allows the company to actually build the car without bleeding to death financially.
Okay, I see your point.
And that is Dovydas' core warning here. In today's hyper-competitive mobility space, one-trick ponies are left in the dust. You cannot just be the company with the best battery chemistry anymore. You cannot just have the most luxurious leather interior. If your enterprise technology stack cannot navigate supply chain friction, optimize R&D, and provide seamless AI-driven customer service after the car is sold, you will be crushed by a competitor who masters the entire lifecycle.
Which perfectly explains why someone with deep expertise in platforms like Salesforce sees the mobility landscape so clearly.
Exactly.
Because he understands that data friction is the ultimate killer of progress.
Sure.
If your sales data doesn't talk to your service data or your analytics platform is lagging, your entire innovation ecosystem just collapses.
The automakers who survive the next decade will be the ones who treat their enterprise architecture with the exact same reverence and massive investment that they currently treat their physical engineering. The digital infrastructure is no longer just a support system.
It's the product.
It is the primary driver of profitability.
So what does this all mean for you, the listener, as you watch this mobility revolution unfold? It means you have to fundamentally change how you evaluate the automotive industry.
Absolutely.
You can't just look at the shiny new EVs driving down your street. You really have to look at the invisible enterprise systems building them, the hyper-local digital mapping enabling them, and the regional economics pricing them.
Yeah.
Because Dovydas' paper makes it incredibly clear that the winners of this global robotaxi and EV race, they're not necessarily going to be the ones who bend metal the best. The winners will be the absolute masters of software and data integration.
Which leaves us with a highly provocative thought to consider based on all this.
Let's hear it.
If survival in the automotive industry now relies entirely on deploying artificial intelligence,
Yeah.
managing global digital twins, and maintaining a flawless, unified enterprise technology stack,
Yeah.
will the successful automakers of tomorrow look anything at all like traditional manufacturers? Or will they essentially just be massive, agile tech companies that happen to build cars on the side?
Wow. It completely flips the script. You aren't kicking the tires anymore. You are inspecting the code. And that is a radically different way to look at the machine sitting in your driveway.